Contemporary Mathematics, Chapter 2, Section 7, Logical Arguments. Figure 2.14. Not all logical arguments are valid, and the ongoing fight for equal rights proves that much progress has yet to be made. Credit goes to them. And it's a picture of progress with some women at the top and a steamroller, and steamrolling the opposition. Learning objectives. After completing this section, you should be able to 1. Apply the law of detachment to determine the conclusion of all statements. 2. Apply the law of denying the consequent to determine the conclusion for positive statements. 3. Apply the chain rule to determine valid conclusions for positive statements. The previous sections of this chapter provide the foundational skills for constructing and analyzing logical arguments. All logical arguments include a set of premises that support a claim or conclusion, but not all logical arguments are valid. The logical argument is valid if its conclusion follows from the premises, and it is sound if it is valid and all of its premises are true. A false or deceptive argument is called a fallacy. Many types of fallacies are so common that they have been named. Who knew? In 1936, Dale Carnegie published his first book titled How to Win Friends and Influence People. It was marketed as training materials for the improvement of public speaking and negotiation skills, and the methods it presented are still used today. Carnegie famously said, when dealing with people, remember you are not dealing with creatures of logic, but creatures of emotion. People who put forth fallacious logical arguments often take advantage of our susceptibility to emotional appeals to try to convince us that what they are saying is true. The study of logic helps us combat this weakness through recognition and learning to focus on the facts and structure of the argument. This section focuses on the two main forms that logical arguments can take. While inductive arguments attempt to draw a more general conclusion from a pattern of specific premises, deductive arguments attempt to draw specific conclusions from at least one or more general premises. Deductive arguments can be proven to be valid using Venn diagrams or truth tables. Inductive arguments generally cannot be proven to be true. They are judged as being strong or weak, but like any opinion, whether you believe an argument is strong or weak often depends on your knowledge of the topic being discussed, along with the evidence being provided in the premises. Hasty generalization is the name given to any fallacy that presents a weak inductive argument. Caution, be careful. Premises may be true or false. If a premise is false, the claims made by the argument should be questioned. Law of detachment. The law of detachment is a valid form of conditional argument that asserts that if both the conditional P then Q and the hypothesis P are true, then the conclusion Q must also be true. The law of detachment is also called affirming the hypothesis, or antecedent, and modus ponens. Symbolically, it has the form parentheses, parentheses, P then Q, close, and P, close, then Q. So we have the law of detachment. The premise is P then Q. The premise is P. The conclusion is Q. Therefore Q. So caution, the three dots like a triangle is right as the word therefore. Looking at the truth table for the conditional statement, the only time the conditional is true is when the hypothesis P is also true. The only place this happens is the first row where Q is also true, confirming that the law of detachment is a valid argument. So we have P, true, true, false, false, Q, true, false, true, true, P then Q, true, false, true, true. Another way to verify that the law of detachment is a valid argument is to construct a truth table for the argument. Parentheses, parentheses, P right Q, close up P, close right Q, and verify that it is a tautology. So P, true, true, false, false, Q, true, false, false, P then Q, true, false, true, P then Q and P, true, false, 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 P then Q and P then Q, true, true, true. Venn diagrams may also be used to verify deductive arguments which include conditional premises. Consider the statement P then Q. If you play a guitar, then you are a musician. The set of guitarists is a subset of the set of musicians. P is a subset of Q. To verify that an argument is valid using a Venn diagram, draw the Venn diagram representing all the premises in the argument only, as shown in figure 2.15. Then verify if the conclusion is also represented by the Venn diagram of the premises. If it is, the argument is valid. If it is not, the argument is not valid. The set of guitarists is drawn as a subset of the set of musicians to represent the premise P then Q. The X represents the premise P is true. This completes the drawing of the premises. So figure 215, universal set is people in a blue rectangle. Then we have the orange set Q, circle, musicians. And the yellow set P is guitarists. Within, it's completely nested, completely surrounded by Q, and then there's an X within P, which means it's also within Q. Now examine the Venn diagram to verify the conclusion is included in the picture. The conclusion is Q. Because the X is in the set P, and P is a subset of Q, X is also in Q. Therefore, the law of detachment is a valid argument. Caution. Remember that an argument can be valid without being true. For the argument to be proven true, it must be both valid and sound. An argument is sound if all the premises are true. Video. Logic Part 14. Common argument forms like modus ponens and tollens. Example 231. Applying the law of detachment to determine a valid conclusion. Each pair of statements represents the premises of in a logical argument. Based on these premises, apply the law of detachment to determine a valid conclusion. 1. If Leonardo da Vinci was an artist, then he painted the Mona Lisa. Leonardo da Vinci was an artist. 2. If Michael Jordan played for the Chicago Bulls, then Michael Jordan was not a soccer player. Michael Jordan played for the Chicago Bulls. 3. If all fish have gills, then clownfish have gills. All fish have gills. Solution. 1. The premises are P then Q. If Leonardo da Vinci was an artist, then he painted the Mona Lisa. And P, Leonardo da Vinci was an artist. This argument has the form of the law of detachment. So the conclusion, Q, is Q. Leonardo da Vinci painted the Mona Lisa. 2. The premises follow the form of the law of detachment. So a valid conclusion would be Q. The premises are P then Q. If Michael Jordan played for the Chicago Bulls, then Michael Jordan was not a soccer player. And P, Michael Jordan played for the Chicago Bulls. The conclusion that follows from the premises is Q. Michael Jordan was not a soccer player. 3. The premises are P then Q. If all fish have gills, then clownfish have gills. And P, all fish have gills. This argument has the form of the law of detachment. So the conclusion is Q. Clownfish have gills. Your turn 231. Each pair of statements represents the premises in a logical argument. Based on these premises, apply the law of detachment to determine a valid conclusion. 1. If my classmate likes history, then some people like history. My classmate likes history. 2. If you do not like to read, then some people do not like reading. You do not like to read. 3. If the polygon has 5 sides, then it is not an octagon. The polygon has 5 sides. Law of denying the consequent. Another form of a valid conditional argument is called the law of denying the consequent, or modus tollens. Recall that the conditional statement P then Q is logically equivalent to the contrapositive, not Q then not P. So if the conditional statement is true, then the contrapositive statement is also true. By the law of detachment, if not Q is also true, then it follows that not P must also be true. Symbolically, it has the form parentheses, P right, Q, close, up, not Q, close, right, not P. The law of denying the consequent, premise, Q, premise, not Q, conclusion. The conditional statement can also be described as if antecedent, then consequent. This is where the law of denying the consequent gets its name. To verify that the law of denying the consequent is a valid argument, construct a truth table for the argument. Parentheses, P then Q, close, and not Q, close, then not P, and verify that it is a tautology. So here's a table. P, true, true, false, false. Q, true, false, not P, false, false, true, true. Not Q, false, true, P then Q, true, false, true, true. P then Q, that's not Q. False, false, true, true. false, 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 true, and then P, then Q, and not Q, then not P, true, 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 true. To verify an argument of this form, using the Venn diagram, again consider the premise P, then Q. If you play guitar and you are a musician, we will change the second premise to not Q. In this case, the X represents the premise of Q. So it will be placed inside the universal set of all people, but outside the set of musicians, like the diagram in figure 2.16. So here we got figure 2.16. We've got blue square set of people. Within blue square, in is Q, musician, which is a circle. Then P, guitarist, is yellow. That's to complete the Q. X is in blue. It's a U. Not Q. Because the X is also outside the set of guitarists, the statement not P follows from the premises, and the argument is valid. Example 232. Find the law of denying the consequent to determine a valid conclusion. Each pair of statements represents the premises in a logical argument. Based on these premises, apply the law of denying the consequent to determine a valid conclusion. 1. If Leonardo da Vinci was an artist, then he painted the Mona Lisa. Leonardo da Vinci did not paint the Mona Lisa. 2. If Michael Jordan played for the Chicago Bulls, then Michael Jordan was not a soccer player. Michael Jordan was a soccer player. 3. If all fish have gills, then clownfish have gills. Clownfish do not have gills. Solution. 1. The premises are P then Q. If Leonardo da Vinci was an artist, then he painted the Mona Lisa, and not Q. Leonardo da Vinci did not paint the Mona Lisa. This argument has the form of the law of denying the consequent, so the conclusion is not P. Leonardo da Vinci was not an artist. 2. The premises follow the form of the law of denying the consequent, so a valid conclusion would be not P. The premises are P then Q. If Michael Jordan played for the Chicago Bulls, then Michael Jordan was not a soccer player, and not Q. Michael Jordan was a soccer player. The conclusion follows from the premises is not P. Michael Jordan did not play for the Chicago Bulls. 3. The premises are P then Q. If all fish have gills, then clownfish have gills, and not Q. Clownfish do not have gills. This argument has the form of the law of denying the consequent, so the conclusion is not P. Some fish do not have gills. Your turn 2.32. Each pair of statements represents the premises in a logical argument. Based on these premises, apply the law of denying the consequent to determine a valid conclusion. 1. If my classmate likes history, then some people like history. Nobody likes history. 2. If Homer does not like to read, then some people do not like reading. All people like reading. 3. If the polygon has 5 sides, then it is not an octagon. The polygon is an octagon. Chain rule for conditional arguments. The chain rule for conditional arguments is another form of a valid conditional argument. It is called hypothetical syllogism, or the transitivity of implication. Recall that the conditional statement P then Q can also be read as P implies Q. This is where the name transitivity of implication comes from. The transitive property for numbers states that if 3 is less than 4 and 4 is less than 5, then it follows that 3 is less than 5. The chain rule extends this property to the conditional statements. The premises of the argument consist of 2 conditional statements with the form P then Q and Q then R, then it follows that P then R. Symbolically, it has the form parentheses, parentheses, P implies Q, close, and parentheses, Q implies R, close, close, implies parentheses, P implies R, close. So we have P, true, 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 false, 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 false. Q, true, true, false, false, true, true, false, false. R, true, false, true, false, true, false, true, false. P then Q, true, true, false, false, true, 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 true. Q then R, true, false, true, 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 false, true, true. And then P then Q and P then R, true, false, 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 true, false, true, true. P then R, true, false, true, false, true, 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 true. And then finally, P then Q, and Q then R, then P then R. True, 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 true. Yeah. To verify an argument of this form using a Venn diagram, again consider the premise P then Q. If you play guitar, then you are a musician, but change the second premise to Q then R. If you are a musician, then you are an artist. In this case, the set P of guitarists is a subset of the set R of guitarists. And it follows that if you are a guitarist, then you are an artist. Therefore, the conclusion P then R follows from the premises, and the chain rule for logical arguments is valid. See figure 2.17. So figure 2.17, blue rectangle, U is people, dark orange circle, Q is musicians, lighter orange circle, P is guitarists, and then light yellow circle, and it goes, yellow circle contains completely within P, that whole circle is contained within Q, that whole circle is contained within R. Sorry,